In example 7, they ask us to differentiate cosine xy equals x plus 3y. Cosine xy equals x plus 3y. Let's go ahead and take the derivative. So the derivative of cosine is negative sine of xy. But I also have to apply the chain rule, which means I need to take the derivative of the inside function xy, and that's going to be a product rule. So we have the first times the derivative of the second, plus the second times the derivative of the first, and the derivative of x is just 1. Or if you want, you could write dx dx, but that's going to give you 1. And on the right side, the derivative of x is 1, or dx dx, plus 3 dy dx. Now let's distribute the negative sine xy. So that's going to give us negative x sine xy dy dx plus negative sine, you know what, let's make that a minus y times sine of xy equals 3 dy dx plus 1. I have dy dx on both sides of the equal sign. I want to get those together. So let me add y sine of xy to both sides. Let me subtract 3 dy dx from both sides. That goes away. This goes away. We have negative x sine xy minus 3 in parentheses. Let's just factor out the dy dx equals 1 plus y sine xy. Now I can divide both sides by negative x sine xy minus 3, and I'll get dy dx is equal to 1 plus y sine xy divided by negative x sine xy minus 3. And you know, that's okay. That's our solution, but I've got two minus signs here, and I could factor that out. That would leave me with 1 plus y sine xy, and then on the bottom we could have negative 1 factored out times a positive 3 plus x sine xy. Now what can I do with that negative 1? Well, we can just pull that out front, and so we have dy dx equals negative 1 plus y sine xy over 3 plus x sine xy. There's our derivative.